All right, Algebra 2, this is a new unit. Unit 4, Lesson 1. And we are going to be working on graphing quadratic functions in standard form. So again, just to review or to remind you, everything that I write down, you should be writing down. You should be copying this into your own notes, whether you're using Notability or a piece of paper. That is my expectation. Again, there's a lot of research out there that says in order to learn best, you have to read it, you've got to see it, and you've got to hear it. So again, writing stuff down and doing it with your own hand helps you learn things. So this is, again, graphing is something that as a class, just in general, we really struggle with and need to continue working on. So again, please pay attention. You have to pay attention to details when you're graphing, or else your graph will not be correct. So we've got these things called quadratic functions. So again, a quadratic function in standard form looks something like this. Standard form. It's going to be something like y equals ax squared plus bx plus c. And again, a cannot equal 0 because then it wouldn't be quadratic. So kind of our basic graph of a quadratic looks something like this. All right, so it's here 1, 2, 3, 4. So again, when x is 1, y is 1. When x is 2, y is 4. And it's going to be consistent on both sides. We have something called the axis of symmetry. Okay, so in this example, this is our axis of symmetry. And this means that if I were to cut my parabola in half, I would have the same image on both sides. You can also think about it like a fold line. If I were to fold this graph over, it would match up perfectly on both sides. And then either the maximum or the minimum of your parabola is called the vertex. And in this case, our vertex is at 0, 0. So we are going to I'm going to ask you to graph functions in the form y equals ax squared. So again, thinking about if this is my parent function, okay, I just don't have a bx and I don't have a c, which is totally fine. So if I were to think about drawing this, let's graph the equation. So this is like, again, the parent function, what we're going to compare it to. Let's look at y equals 2x squared. So this is what I'm going to graph, y equals 2x squared. So in order to do this, I'm going to make a table of values. So I'm going to make an x column or an x row and a y row. And I'm going to just start making, so I'm going to choose my x values that I want. And usually if you go from -2 to +2, you can usually get a pretty good sense of the data. So if I plug in a -2 into my equation, so again, equals 2 times -2 squared. So when x is -2, y is going to be, this is 2 times 4, y is going to be 8. When x is -1, y is going to be 2. When x is 0, y is 0. When x is 1, y is 2. And when x is 2, y is 8. So again, I could graph this. I'm going to go 2, 4, 6, 8, 10. I'm going to go 1, 2, 3, -1, -2, -3. So when x is 0, y is 0. When x is -1, y is 2. When x is -2, y is 8. When x is 1, y is 2. And when x is 2, y is 8. That's enough points for me to graph what my parabola should look like. So that's what it would look like, again, if my function was y equals 2x squared. So this is the function y equals 2x squared. And if we wanted to compare that to our parent function, again, we can use Desmos. Desmos is very helpful for this. So our parent function is x squared. That's what we're used to. That's our basic parabola. And this time we have 2x squared. So you can see, hey, it's a little bit skinnier because again, I'm multiplying each of my x values by 2. So my graph is similar, but because it's getting multiplied by 2, it's going to be skinnier. All right, we might also have a function that looks like y equals ax squared plus c. So again, keep that in mind. That's kind of the general form that we're going to use. And the graph that we're actually going to make is y equals negative 1/2 x squared plus 3. So this is what we're going to graph. So for starters, I'm going to graph y equals x squared just so I have something to compare. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 1, negative 2, and negative 1, negative 2, negative 3, negative. So my parent function is 1 and 1, 2 and 4, 3 and 9, 4 and 16. It's going to look something like this. So that's what we're going to compare it to. And again, to solve this, I'm going to make my table of values. So in this case, and you'll kind of, as you do more of these problems, you'll kind of realize why I'm picking some of the values I am. But I'm going to make an x, I'm going to make a y. And because it's got a factor of negative 1/2, I'm going to count by 2's. So I'm going to go negative 4, negative 2, 0, 2, and 4. So if I plug in negative 4 into my equation, y equals negative 1/2 negative 4 squared plus 3. That's 1/2 times 16 plus 3. Let's see here. 1/2 times 16 is 8, and 8 plus 3. Oh, this is a negative. Excuse me. I almost goofed that up. So that's a negative 8 plus 3, which gives me negative 5. So when x is negative 4, y is, got to make it a little bit longer. When x is negative 4, y is negative 5. Now let's plug in a negative 2. So I'm going to solve this problem. Negative 1/2, plug in a negative 2. Negative 1/2, 2 squared, or negative 2 squared is 4 plus 3. Negative 1/2 times 4 is negative 2. And negative 2 plus 3 equals positive 1. So when x is negative 2, y is positive 1. Now when I plug in 0, I'm going to get 0 plus 3. That's going to give me 3. So I can know that when x is 0, y is 3. And then it is going to be mirrored on my other side. So again, I know that this is going to be 1 and negative 5. So when x is 2, y is 1. And when x is 4, y is negative 5. So if I connect my dots, I get a parabola that looks like this. Again, why did it flip upside down? It flipped upside down because of this negative. It had a factor of 1/2. So again, that's why it's wider. And then it had a vertical shift of up 3 or plus 3. So that's why we added 3. We could use Desmos to do that as well. Okay, let's see here. So just some characteristics, kind of, again, good things to put into your notes. Looking at our base kind of function, plus bx plus c. If a is greater than 0, it opens up. So again, that's my first value right here. And if a is less than 0, it opens down. And we kind of did some examples. So again, if my a value, and I can look at it as the absolute value, if my absolute value is bigger than 1, it's going to be more narrow. Which was like our first example, where again, this one, our a was bigger than 1. So it's more narrow. And then if it were to be less than 1, my absolute value would be less than 1, then it's going to be wider, which was this red example here. Again, it's more wide than my original graph. To find your axes of symmetry, to find, again, what's that line that you could fold it in half? You take x equals negative b over 2 times a. So again, a is in the same spot, b is right here. So I can take negative b over 2a, and that's going to give me a vertical line that I can calculate. And then the y-intercept is c, and that shouldn't be new for us. Y-intercept equals c. So again, looking at my parent function, and so if it were to be an ordered pair, it would be 0c. And then again, this would be my x coordinate right here. Okay. Let's do one more example here. Graph the function y equals 2x squared minus 8x plus 6. So identify the coefficients of the function. So again, highlighting stuff that I see. I see my a is 2, my b is negative 8, and my c is 6. So let's kind of highlight that. A equals 2, b equals negative 8, c equals 6. So let's find our vertex. So our vertex, again, if we think about that, is going to be our x coordinate, which is, we can find the axes of symmetry, and then my y-intercept, which is c. So again, to kind of find our vertex, it's going to be like taking negative b over 2a and c. That's not quite true, excuse me. So again, that's how we find our x coordinate. To find our y coordinate, we have to plug it back into our equation. So we can find our vertex by saying, okay, I'm going to find my x coordinate by saying negative b. So again, negative 8 over 2 times a is 2. Negative 8 is positive 8. 2 times 2 is 4. So that means that my x coordinate is going to equal 2. So again, if I'm looking for the vertex, I know, okay, my x is 2. Now, I know what y is right here. So I'm going to plug in every time I see an x, I'm going to plug in a 2 to figure out what that y is. So y equals 2 times 2 squared minus 8 times 2 plus 6. 2 squared is 4, so this is 2 times 4. 8 times negative 8 times 2 is negative 16 plus 6. 2 times 4 is 8 minus 16 plus 6. And let's see here, 8 minus 16 is negative 8 plus 6. So my y-coordinate is negative 2. So we can start by drawing that, okay? So again, if I'm going to graph this, I'm going to say, all right, I've got something like this, and I know that my vertex is at x is 2, y is negative 2. So here's my vertex. I know that my axis of symmetry, which we found when we got our x coordinate, is the line x equals 2. So this is kind of going to be the halfway point. I've got to figure out my y-intercept, which again, y-intercept is our c value. So my y-intercept is going to be at 6. So if I start labeling my graph, 1, 2, 3, 4, 5, 6. Here's my y-intercept all the way up here. And I can reflect this as well. So if I look and I say, all right, from my axis of symmetry, I have, see here, 1, 2 units to the left. So I can reflect that and go 2 units to the right and put that point in the exact same spot. So that's going to give me this point of 6, 4. And I should probably try to figure out when x is 1, since I have a 0 and I have 2 and I have 4. If I find when x is 1, I'll also know what x is when it equals 3. So again, my original function is minus 8x plus 6. If I plug in a 1, 2 minus 8 plus 6 equals 0. So when x is 1, y is 0, I can now connect my lines, create my parabola, and then again, I reflect it. That's a distance of 1, so this one has to be right here as well. And that's what my graphed parabola is going to look like. So a lot of steps into it. If you were to use Desmos, we can check our work. Again, you are going to have to do it by hand, so it is important to know how to do that. But if I graphed it and checked it out, I would say, okay, let's see here. I had a y-intercept of 6. I had a vertex of 2, negative 2. 0 is at 3 and 1. And then the only thing you'd have to know is what is your axes of symmetry. And again, that's the line x equals 2. That gives me my axis of symmetry. So things that I would look for, again, I would look for the things you need to have. You need to have a y-intercept. You need to have x-intercepts, plural. You need to have an axis of symmetry. And you need to have a vertex. Again, a reminder for your vertex, if it opens like this, the vertex is a minimum. And if it opens down like this, your vertex is a maximum.